Okay, so in today's DBMS class, we are going to study about mapping cardinalities and keys. Okay, so in previous class, we have studied about entities and relationships, and now today we are going to see some mapping cardinalities which is related to those entities and relationships. Right now, in today's class, what we will be doing, we will be studying about each and every mapping cardinality. So what are they? One to one, one to many to one, and many to many. Okay. Now, each and every, what is mapping cardinality? First of all, we have to know about that. So, mapping cardinalities or cardinality ratio. It is also known as cardinality ratio. Either it is called mapping cardinality. Why? We are mapping something from A and B. These are the two sets, and we are going to map each and every element of these two particular sets. Okay. Now, mapping cardinality is also known as cardinality ratio. What is the cardinality ratio? That is 1:1, 1:n, n:1, and n:n. Right? Now, this is what is called the cardinality ratio. So, these two things are same. If you are going to be asked for mapping cardinality or cardinality ratio, the answer will be same. Okay? Now, let's see. So, mapping cardinalities or cardinality ratio express the number of entities to which each entity can be associated via a relationship set. So, here we are talking about each and every entity that is going to be related with each other with the help of some relationship set. That is, express the number of entities, right? Number of entities means how many entities are there present. So, those number of entities to which each entity can be associated. There are some number of entities, and how the other entities, each and every entities of the other set is going to be associated via a relationship set. Here we are talking about a relationship set. In previous class, we have seen what was the entity set, what was the relationship set. You can see in the previous class video, that what was that one. Okay, I am not explaining that in this class. So, this was about entity set and your relationship set. Now, today, how we are going to make the mapping between these entity sets via a relationship set. We have seen the mathematical expression also in the previous class. Now, this is what is going to be done in this mapping cardinality. What we are going to do? We are going to just relate or map each and every entity with the other entities via a relationship set. Okay. Now, so for a binary relationship, binary means 2, 0 and 1. Relationships are between entity sets A and B. This is my entity set A and B. Okay. So, A and B are the two entity sets which are having some entities. Okay. Now, the mapping cardinality must be one of the following. One can be 1 to 1, 1 to many to 1, and many to many. Right? Now, what we are going to see? We are going to see how these particular entities are going to be related. As you can understand from the name only, you are just going to see how this mapping is going to be done. But from the name only, you can understand that how the things are going to be done. Okay. So, mainly it is the mapping between two entity sets. These are the two entity sets A and B via some relationship. How the relationship is going to be done between each entity, how we are going to just express this entity, how we are going to just map these entities with the help of some relationship. So, this is what is going to be done here. That is the mapping. Mapping means the relationship. So, the relationship set is what is going to be just doing the mapping between two entity sets. Each and every entity, how it is related to the other entity with the help of a relationship set. That particular thing is going to be shown by this mapping cardinalities, right? Now, here, first of all is 1 to 1. From one entity to the other entity. Okay. So, 1 to 1. From one from here and the other from here. This mapping will be done between one entity. 1:1. Right. Now, an entity in A, that is from here, we are having 4 entities. A1, A2, A3 and A4. So, from one entity from this particular entity set, what is going to do is associated with at most one entity in B. At most means, at least means that up to more, maybe it can be more than, but at most means it can be at most with one entity, less than equals to maybe one or maybe none. So at most one entity in B, that is it can be, or it should be less than either 1 or 0. So one entity in B, and an entity in B is associated with at most one entity in A. So here what is going to be there? 1:1. That means what? An entity from set A can be associated or related to another entity, maybe at most one entity. That means either 1 or 0 entity of the entity set B. Same, vice versa. An entity from B, set B, can be associated or related with another entity of set A, at most one entity, right? So entity of A, this set A, is associated with at most one entity in B. Again, an entity in B is associated with at most one entity in A. You can see here A1 is associated with B1. 1, right? Now A2 is associated with B2. Again 1. A3 associated with B3. Again 1. But A4 is not associated with anything. So since we have told about at most, so maybe the entities of any either set A or B can be associated with the another set element entities, okay, but there can be an entity in the set, both the sets, which cannot be associated with any entity of the another set, okay, because at most had been used. It is not said that an entity from set A should be mapped with or related or associated with another entity of B. It had been told there at most an entity from set A can be associated with at most one entity of set B. Same entity from set B can be associated with at most one entity of set A. So each and every entity of a particular set, maybe A or B, either your A set or B set, is associated with another entity of the other set, but it should be at most, not more than one. Either it can be associated with one entity of the next set, or there can be an entity which is not associated with any entity of the other set. So this is what is called one-to-one relationship. That is, each and every entity should be related to the other set entities, but at most one. It can be the association is at most one, not more than one. So here it is the figure of your entity relationship, your one-to-one cardinality ratio, right? So here this is going to be 1:1, 1, 1, but after this A4 it is not having any entity where can be associated in B set. Since one-to-one association is there, we cannot associate it with any other entity, since it is one-to-one, and so it is single there. It is not associated with any other entity. At most is there, so it is perfectly okay, right? So this is what is the figure which will be explaining you about one-to-one mapping cardinality or your cardinality ratio for one-to-one relationship, okay? Now this was the first one. Now second one is one-to-many. One-to-one defined. Now one-to-many is one from any set mapped with many, means more than one. Here it can be more than one. There was at most one, but here we can just relate it with anyone, okay? An entity in A is associated with any number, 0 or more. It can be 0, maybe, or more, right? Any number can be 0 or can be more, any number, right, of entities in B. So here it can relate with any number, either 0 or maybe more than 0, okay, any number. So with this B, an entity B, however, can be associated with at most one entity in A. But B, when we are talking about B, it can be associated with at most one entity of A. Here we can associate it with many, but here you can see at most one. Again same thing. Here one to many to one, that is another thing. One to many. We are talking about a set, when here we are talking about a single set. Okay, so here it will be about one to many, right? Like you can see here, it is about one to many. So here we are talking about this one. This is A and this is our B, right? Now one to many means this one. Here we are having some elements or entities A1, A2, A3. So here are my elements, entities, sorry, and here B1, B2, B3, B4 and B5. These are my entities of the next set, right? Now what we have to see, this is one to many, right? Now when we are going to explain about one to many, we have to see that 0 or more than 0, right? So what we have to see, this particular element can be just mixed with, or it can be associated with one element 0 or more than 0. Then again A1 can be associated with B2 also, because more than 0 can be there. I can associate it with many, means more than 0. It can be 1, it can be 2, it can be 3, it can be many in number. Okay, so now again A2, B3, B4, A3 with B5. So this is 1, this is 2, this can be 3 also. So it can be any in number, but you have to see that this A and this is B. First we are talking about 1 to n. So this relationship 1 is to n can be, how we are going to define that one? 1 to many. We are going to define like this, 1 to many, right? But vice versa is not applicable here. Like we here only at most 1. That means B1 is associated with B2. Again here A1 is associated with B2 is associated with A1. B3 is associated with B2, B4 with, but here these elements are associated with any one of the particular set. Here the elements are not associated with these particular many. No, these are going to be associated with only 1 to 1. This one to this one to this, right? Again this to this. So these are being associated with many. A1 is associated with 2 particular entities, right? Again A2 with 2 particular entities and A3 with 1. It can be 0 or more than 0, but B1 is associated only with A1. B2 is associated only with A1. B3 is associated only with A2. B4 only with A2 and B5 only with A3. So these elements are again that at most 1. These are again, these cannot be many to 1, right? So these are associated with only with 1. Like these elements, then these elements are with 1 to many. But these elements are not from 1 to many. B1 is not associated with A1 also A2. No, it is only associated with A1. Again B2 is associated with only with A1. Maybe there can be some element in B which is not associated with any element of or any entity of your A set. Okay, maybe there can be B6 which is not associated with anything, right? Again here also there can be A4 which is not associated with anything here. But you have to see one thing, that is any set here, it can be 1 to many, but it cannot be from here to here. Here to here, again that at most factor is there. That is not more than 1, right? So these factors should be seen. Here we were doing what? Same. At most for this case, 1 or less than 1. Again here also A to B 1 or less than 1. B to A also 1 or less than 1. But when we are talking about this one, this particular section, here A can be associated with any number of, maybe A can be associated with all the elements also. Maybe A can be associated with 2 elements, 3 elements, 4 elements. But when we are talking about B to A, B is only associated with one and only one entity of set A. Since that at most factor is going to be there. Here vice versa is not applicable, right? So here B1 is associated with A1, B2 with A1. So one element they are associated, right? So it is also there, it can be either 0 or 1. Then, but when we are talking about here, A1 is associated with two things, B1, B2. So two things it is associated with, 0 or more than 0. But in case of B, only 0 or 1. There cannot be more than one relationship between B to A. But to A to B, 0 or more than 0. Okay. So this is 1 to N. 1 is to N. 1 to many. But N to 1 is another one. Okay. And N is to 1 is another relationship. So here only 1 is to N. You have to keep that in mind. 1 is to N. But vice versa is not applicable for this case. Right. So A can be associated with any number of either 0 or any number of elements or entities in the B set. But B set is only associated with at most one entity of A set. This is what is there in your 1 is to N. Then now next one is your many to 1, where we are going to do the next thing, right? What we are doing here, the opposite thing is going to be here. An entity in A is associated with at most 1. Again here what is going to be there? A1 is associated with B1, A2 with B1, A3 with B2, A4 with B3, A5 with B3. So they are associated with at most one entity of B. But here B however can be associated with any number, 0 or more of entities in A. B is associated with A1, A2, B with B3, B3 with A4, A5. Here the opposite thing is going to be happen, right? Here what is happening? These two are my set, A and B. What is going to happen? A1, A2, A3, A4, A5. Here B1, B2 and B3. So now what we are going to do? For A, at most 1. I means 0 and 1. So we have to take care. A is associated with B1, A2 associated with B1, A3 associated with B2, A4 with B3, A5 with B3. So you can see this is the relationship 1, only at most 1. But opposite, since it is many is to 1, right? N is to 1. So here what we are going to do, B1 is associated with both A1, A2. B2 is associated with A3. B3 is associated with A4, A5, maybe A6, whatever. So it should be 0 or more than 0. It is 0 less than equals to 0. Right? So N can be associated with anything. Either 0, maybe there can be an entity in set B which is not associated with any entity of set A. Again, there can be any entity in set A which is not associated with any entity of set B. So these are the two particular things which you have to keep in mind. It is not very complicated, but the concept should be clear. In 1 is to N, when we are talking about 1 is to N, at that time these are related to 1 is related to many. 1 is to N. 1 related to many, but vice versa is not applicable. Again here N is to 1 means many, there can be 1 which is related to, so many can be related to 1, but again vice versa is not applicable. So these are the two concepts which is very necessary when you are studying about the mapping cardinalities, right? So again many is to many is again another relationship, but in first relationship you were seeing that any element, any entity from A is associated with any element of B, but the relationship had a unique thing, that was at most 1, only 0 or 1. any entity from A can be related to either 0 or 1, at most one entity of set B. Again, any entity from set B can be related to at most one entity of set A, right? Here what was happening, any entity of set A can be related to 0 or more than 0 entities of set B. Again, there any entity of set B can be related with at most one entity of set A. That was for 1 is to n. But n is to 1, any entity of set A is associated with at most one entity of set B, but any entity of set B is associated with many, that is 0 to more entity of set A. So this is the thing what is done between these two sets. This you have to keep in mind. Otherwise it's very easy, but a little bit concept is there, that 1 is to n and n is to 1. This is the main thing, and this is what is happening when we are talking about the entity set. That's why we have studied about what was entity set and what was relationship set, because from that entity and relationship set we are going to get this particular thing, that is our cardinality ratio. It is very important for your examination also. Now this is what is happening in these two particular things. Now we have to talk about the last one, that is many to many, n is to n. Again here vice versa can be applicable, right? So here again what is happening, two groups are there, two A and B sets are there. You can see that A is associated with 2, A2 is associated with 1, A3 is associated with 1, A4 is again associated with 2. So here many to many, one can be related to many, many can be related to one, or none, right? So here an entity in A is associated with any number of entities in B, entity in B is associated with any number of entities in A. So here again there can be any entity in A, set A, which can be associated with 0 or more than 0, okay, more in numbers, with any entity of B. Again, any entity of B can be associated with 0 or more than 0 entities of set A. There can be an entity in A and B, both groups, which is there, which cannot be associated with any number of entities in A or B either. Okay, so there can be a entity. So here B4 is our entity which is not related with any entity of set A. So here 0, again more. So B is related with A3, A4, A is related with B1, B2. So this is satisfying the relationship n is to n. This is what is happening in the whole cardinality ratio, how we are going to thus associate each and every entity of your both the sets. Okay, each and every entity, how we are going to associate them with the help of relationship set. And this is what is the relationship, this is the relationship it is going on. And this many to one, one to many, this is the relationship cardinality, how the relationship is going to be shown, right? So here how we are going to show the relationship, how each and every element, each and every entity, they are going to be associated or they are going to be related. That is the thing which is shown by this cardinality ratios. Done. So these are the particularly 4 cardinality ratios done. Now key, we are going to study about key. What is a key? With which we are going to open a lock, right? Here what is a key? Key is the main factor. Okay, there are so many types of keys in DBMS by which you are going to identify a particular entity. Okay, so keys are basically here, different keys are there, primary key, candidate key. Each and every key have a unique definition by which you will understand that how the key is going to work in your table. When you are going to make the table, that is your database, so those tables, they have some types of keys, and these keys are going to show how we are going to relate the tables and how they are going to work in a particular table. They have some names and also they have some functions. One by one we will see the different keys. Okay, so first of all, what is a key? A key for an entity is a set of attributes that suffice to distinguish entities from each other. So in a particular table how we are going to distinguish between two particular entities. So with the setup is a set of attributes. These are some attributes by which we can distinguish between two particular entities. So basically we are going to here, whenever we are talking about the keys, these keys are basically set of attributes. What are the attributes? Attributes are the properties of a particular entity. As we have studied in previous class also, what were attributes? They are the particular properties of an entity. So here also we are talking about the particular entities, how the different entities we are going to just see that how they are going to be distinguished. Attributes only distinguish between two particular entities. So these are set of attributes, means not one attribute, they are set of attributes which are going to be just, it is just making some uniqueness, it is just distinguishing between two entities, right? So keys also helps to identify relationships uniquely. Also they are used to distinguish, or they are used to identify the relationships uniquely. How the relationships are uniquely identified, that is also done with the keys. Thus, and thus distinguish relationships also from each other. So keys are very important here. They are going to distinguish between two particular entities. Also they are going to identify the uniqueness of your relationship, as well as they are also going to distinguish between two particular relationships also. So basically keys are very important in case of your DBMS. When you are working with that one, each and every time we are having some definition in DBMS, but when you are going to work practically in your particular database, practical classes, at that time you will come to see that how the keys are working. This is the theoretical place where you are going to study about this thing, but practically when you will work, you will understand what is the behavior or what are the different keys, how they are working, right? So basically keys are, a key for an entity is a, each and every entity have some key, right? So key is a set of attributes that suffice to distinguish entities from each other. Keys also helps to identify relationship uniquely, and also they distinguish the relationships. Okay, so now one key we will study. Okay, each and every key. So types of key, there are basically 4 kinds of keys which you are going to study. First one is the primary key. Primary key, I have already told you many times in the previous classes what are that one. We will study today also. Second is the candidate key, right? Third is the super key, and fourth one is the foreign key. Foreign key relates to foreign, as you know that it is from another country, right? So, or another place. So this is what the foreign key does. It just mix-ups, or it just relates to tables, or when you are going to work with two particular databases, it is just going to relate that one, right? So that is what is the function of your foreign key. Now first of all we are going to study about the primary key, the basic key, which is going to be the main criteria of your database. So primary key is that key which is going to uniquely identify, that is your attribute which is going to uniquely identify any particular column, right? Like let's see here how we are going to just see this primary key. Primary key is basically the, it shows you the uniqueness by which you are going to identify a particular thing. Suppose you here in case of employee, if we are studying about the employee, right? Here the employee table, if we are going to study about, so here should be some employee ID, right? Now employee name, maybe the address, etc, etc. So, to identify a particular thing, right? To identify a particular employee, what do you need? You need the ID. Maybe a place, there can be two employees with the same name, right? There can be two employees with the same name. You cannot identify a particular employee by his name. No, because two employees can be there whose name can be same. Again, you cannot identify by their address. Maybe two brothers or two sisters, or a brother or sister from the same family, or maybe two friends from the same apartment can be there in a particular company. So you cannot identify them by the address. Maybe two people are coming from the same mess. So the address of these two peoples are same. So you cannot identify them by the help of their address. Phone numbers, yes, you can identify them with the phone number, but maybe the phone number can also be same. From two person are coming, they are brothers and they are sharing the same phone. The telephone number can be also be same. But you have to see a particular thing which will uniquely identify a person, right? Uniquely identify a person with the help of your employee ID. Employee ID can be a thing which can uniquely identify a person in the whole office. Wherever that particular employee ID is put in the database, that particular person is identified. So employee ID in this case is the primary key. Employee ID is the primary key where we are talking about the employee table. Okay, so it is relational database table column by, this is the column and this is the row. So we each and every time we are talking about a column. Whenever column means what? Data of each and every person. Row means data of a particular person, right? Here row means what? Suppose this is A001, B001. So they are different people. So in case of this particular thing, this particular row will identify a particular person. It is the details of a particular person, attribute of a particular entity, a particular person, that is A001. But this is what the column identifies. What it identifies? About all the people, all the entities, right? It is talking about all the people of a particular employee or a particular department, right? So columns identify each and every entity, but the rows identify the properties, attributes of a particular entity. Done? Now, so it is, what is the primary key? It is relational database table or column, right? Or combination of columns designed to uniquely identify all table records, right? Now, what are the features? So, uniquely identify. The main thing is uniquely identify. Whenever you are going to work with the database, it is very important that there should be a key. There should be a particular key which should be there, by which you can identify all the other things, all the other datas of a particular table. Either if you have some different kinds of things, like you have the name difference, they are there, but uniquely identifying a particular column is very important, or uniquely identifying the data of a particular table is very important when you are working in a database, with the database. Okay, so here primary key, the basic definition of primary key is what? It uniquely identifies. It can be database table, column, or combination of columns. It can be the combination of column also, right? Like employee ID, in this case we are having the employee ID. Also in some cases there can be combination also, like some ID is given, also some password is there. So this ID and password, these are unique for each and every person. So at that time the ID and password will be the unique thing by which we can identify a person, right? Because passwords and IDs are, so this particular column, that time the combination of columns can be taken. But when we are talking about this particular section about the employee table, so here the employee ID is sufficient to just show you or just uniquely identify the particular employee of a particular department. So employee ID is the primary key. Again, if you are talking about the customer, you have some customer table. So there also there should be some customer ID, right? Some name, etc, etc. So here the customer ID will be the primary key which will uniquely identify a particular customer in a particular whatever department we are going to study, we are just working with, right? So again, customer ID is in case of a student, the student ID. In case of any university, the staff ID, right? So these are the IDs which is basically it is used as the primary key. Very just, it's very normal to identify with the numbers only. That is the uniqueness has been given by this IDs only. So if in any case some password is there, you can take that one also. That is the combination of columns can also be taken. So this is that a table column, or it can be combination of columns. Now, what are the features of primary key? There are some features by which that is some criteria which should be followed while making a primary key. What is that one? It must contain an unique value for each row of data. As I have told you already, each row of data is identifying each and every different kind of person. So when we are talking about this particular table, okay, so this particular table, if A001, A00, B001 or A002, A00, so these are what? These are unique persons. So there should be a value which uniquely identifies each row of data. These are the row of data for each and every person. These are different person 1, person 2, person 3. And this is the data of each and every row is the data which is related to a particular person. So you have to choose that key, that particular column which can identify uniquely each and every row of your table. Each and every row means each and every person of your table. Row means each and every data of a particular entity. These are the different entities. A001, these are different people. And this is what, these are their attributes, different attributes. So employee can be having employee name, address, their email ID, phone number, etc, etc. So this is what is happening here. You have to see that the primary key, whatever column you identify, that is the column which uniquely identifies a particular row, right? Now, next is, it cannot contain null values. Obviously, when you are going to find out about any person uniquely, so that particular column cannot have some null values, because whenever you are going to give some employee ID to a person in a company, or you are going to give some roll number to a person, if some person exists in the company, then obviously that person will have some employee ID. If a student exists in a college or a university, so obviously that student will have some particular data. So this should be unique. First of all, this should be unique, right, for each and every row, and it should not be null. The value should not be null. Why the value should not be null? Since if any person is there in a particular place, or any entity is existing, then obviously it will have some ID. So this place cannot be 0. If he is leaving, the ID is closed, or the ID is deleted. But there cannot be a person who don't have any ID. There cannot be a student who don't have any roll number. So this is the particular thing what is happening. So this is uniquely identifying a particular row, as well as it cannot have a null value. This is the two criteria what is necessary when you are going to identify your primary key. Whenever you are having the table, you have to see that column, choose that column which is identifying each and every row uniquely. First. Second, you have to see that particular column should never be 0. They cannot have the null value. It should have some value. If it doesn't have any value, then how it will uniquely identify your particular row? So it cannot be null, and it should identify that particular row uniquely. Then, now, it is either an existing table column or a column that is specifically generated by the database according to a defined sequence. So either it can be an existing column when I am going to define the primary key of my particular table. So what is going to be there? Either it can be an existing column which is already there. I am working with that column. It is placed in that particular table, or maybe it can be generated by the database according to the defined sequence. According to the sequence means whatever sequence is going on, according to that defined sequence, the particular column which is identifying the particular row, each and every row uniquely, as well as doesn't have any null value, with that sequence what is going on, right? So with that particular sequence, the database will generate automatically, that will generate a particular column. which can be either existing, from there you can take, or the database will generate it according to the going on sequence. Whatever sequence is going on, according to that sequence, the database can or generate that automatically, right? So specifically the database will generate that particular column, but each and every table should have a primary key. There cannot be any table where the primary key is not present. Whatever database you make, whatever table you are going to work with, you will have a primary key. It is the basic thing of your database, as well it is the basic thing of your table, right? So basically this primary key is the main thing, the basic thing of your database. Done. Now example, in a customer table, customer ID will be the primary key. Obviously I have shown you that here employee, again you can write the customer, so customer ID will be the primary key, that thing which is uniquely identifying each and every row, that is each and every entity, as well as it should not be zero. Null values cannot be taken here. So this is what is happening with your primary key. Done. Now next one is your candidate key. Okay, so we are talking about a candidate key. What is a candidate key? Candidate key is what? It is a column, a set of columns. Again we are talking about set of columns. Maybe one column or maybe set of columns, right? In a table that can uniquely identify any database record without referring to any other data. This particular key will again uniquely identify what? Identify a whole database record, right? Here it is a column, a set of column in a table, particular table, that can uniquely identify any database record without referencing to any other data. Without referencing means we are not taking any kind of reference here, but it is sufficient to uniquely identify a whole database record. Whatever database record I have, it is going to identify it uniquely, the whole database record. It can be a column or a set of columns, combination can be also there, but it will uniquely identify a whole database record what I have without referring to any other data. You cannot refer to any other data. Whenever you are talking about candidate key, it is not going to have any kind of reference, but it is from the table itself. You are going to work with the table itself. It is not going to refer with any other table. It is going to uniquely identify the database, but the data, whatever, you can take a column or combination of column, but that particular thing within the same table. It's not going to reference with any other data, right? Within the same column. Okay. So each table may have one or more candidates key. Whenever we are talking about this candidate, primary key is always one and only. It is unique. But candidate keys, when we are talking about, it can be candidate key or candidate keys. More than one candidate key can be there in case of your particular table. Okay, primary key only one, candidate key more than one. That's okay. Now, but one candidate key is special. One candidate key is special. All of the candidates key, there can be more than one candidate key, but one candidate key is very unique, very special. Now when we are talking about uniqueness, what comes to our mind? Your primary key. That candidate key which is unique, one candidate key which is unique, that is our primary key. So now what is the definition of your primary key? Primary key is a type of candidate key which uniquely identifies a particular row and each and every row, and what it does not have any null values. So this is the thing, that is candidate key can be more than one. They are also uniquely identifying. Since they are uniquely identifying, primary key is one of them, but that is a special key, special candidate key, which is our primary key, which is uniquely identifying a particular column, right? And candidate key can be more than one, primary key is only one, right? So this is what is there in your candidate key. Again, this is usually the best and the candidate is best among the candidate keys. Why it is best? Since it is not needing any other reference. The candidate key, what is the definition? It should not have any referencing data. As we have seen in the primary key, what we have seen, we can take a particular column or we can take more than one column. But what is the unique thing? That it is uniquely identifying a table records. The whatever table records we have, it is just uniquely identifying. It is not referencing anything. So the main definition is what? Uniquely identifying the database records, but without referencing any other data. Here also what is happening, the candidate key, that is our primary key, that is a special one and the best among all the candidate keys. Why it is best? Since it is uniquely identifying and it is not referencing to any other data. It is within the table itself. So candidate key, you know what is now? That is uniquely identifying the database records, and also what thing? It is not referencing to any other data. Primary key is the special kind of candidate key, as well it's the best candidate key since it is not referencing and it is the unique one, the best one among all the candidate keys. Now let's have some example. In case of a student database, ID can be a candidate key. Okay, now student database, here we have the student database, right? Now here we have the student ID, right? Now again there should be some name, department name, right? And etc about data whatever details are there. So first of the thing we are going to study, that is the ID is also candidate key. Why ID is the candidate key? Since it is the, whenever you are going to show which one is the primary key, like this one, so you have to make an underline. This will show that this is my primary key. Okay, so in this case student ID is a candidate key. Why? Since it is my primary key. Student ID is my primary key. So obviously it's the candidate key also, and it is the best candidate key. Best among all, best candidate key, as well as the special kind of candidate key. So here in case of student ID can be a candidate key, right? It can be a candidate key since it is my primary key. Done. Now next we are telling that there can be number of candidate keys. How? Let's see. Now also name and department name can be a candidate key because they can uniquely identify a student. Again what? Name and department name, these two combined can be a candidate key. These two combined together, name and department name, maybe that can be, maybe cannot be, because since suppose a person who is, suppose A Kumar, okay, so he is studying in, his name is A Kumar and he is studying in your IT department. Maybe again some person with the same name can be in the CS department also, but this happens very unusually, right? Rare is that case is very rare. But basically what happens, a person with a particular name, his surname, whole name, the name, surname, middle name, everything is well included. So okay, not only the same name, it is also it is containing the first name, middle name, as I have already shown you this thing, surname. So these, including these all things, were the name and the department name. So a person with a particular name is there in a particular department. So this is the combination. This particular combination can be a candidate key. It can also uniquely identify a table. But the basically what I have told you already, that the special and the best among the candidate keys is our primary key. So this can be a candidate key. Yes, it can uniquely identify. With the help of the name and department name combined together, you can identify a person, you can identify a student. But uniqueness is what? Your student ID. Why student ID? Because that cannot be copied, that cannot be repeated to another student. Maybe the name can be a name can be there, that the same name person can be in the next class also, in any other department also. But same name, same person. How we are telling that it is a candidate key? Why? Same name, same department cannot be there. So name with same department person can be uniquely identified. Same name person and the department when taken together, if we are taking with the single with the name, there can be more than one person with the same name in another department. But again, department, each and every person have the same department of a particular department. But when uniquely you are taking this together, suppose a person with A and this is IT. So this particular person with the name and department ID is uniquely identifying a person. Again, B with CS. So it is also uniquely identifying. So there is the unique data. But this one is the best one, since this cannot be copied or this cannot be repeated. So the best among the candidate keys is our primary key. Again, but ID and name together cannot be taken as candidate keys, as ID alone is a candidate key. What we are telling here, that this ID and name cannot be taken together. We can take the name and department together as a candidate key. But why we cannot take the ID and name together to identify a particular person? No, because your ID is sufficient. It is individually sufficient to identify a person. When a particular column is sufficient to identify a particular person, you cannot combine it with another things, right? Name is not sufficient to identify. As I already have told you, that name is not sufficient. One name person can be in other places also, maybe in the same department also, but one name, so your name cannot uniquely identify a person. Your department can never identify a person, because there are many people from one department itself. But when you are taking these together, the name of a person and department, that maybe can identify a particular person. But you cannot take the ID and name together to identify a particular person. Why? Since ID is sufficient individually, it is sufficient to uniquely identify a person. So ID individually is sufficient. So you cannot combine your ID with any other thing. Since your ID is sufficient, that is, your ID is strong enough to identify a particular people. They can identify the particular table or the data of a table. So ID you can take just individually. So you cannot combine that with any other thing. But name and department you can combine with other things. That now this is what is there in the candidate key. Then now we are going to talk about the super key. What is super key? So candidate key is clear. When you are having a key which can uniquely identify particular column, so you cannot mix up or combine it. When it is sufficient, why you are going to combine that one? It is sufficient to identify, so it can be used individually. So why combination should be done? But when something is not sufficient to individually, it is not sufficient to just identify a particular column, so that time we are combining two particular columns, right, to identify the data. But when one is sufficient, you have not to combine it with any other thing, right? Now next is super key, right? It is a combination of columns. It is a combination of columns, right, that uniquely identifies any row within a relational database management system, RDBMS, that is relational database management system. We will study later. Table. A candidate key is a closely related concept where the super key is reduced to minimum number of columns required to uniquely identify each row. Here also the same thing. It is also uniquely, but it is a combination of tables. It is a combination of columns, right? Combination is column means here you cannot take one column. It is the combination of columns that uniquely identify any row within a relational database, RDBMS. Now, a candidate key is a closely related concept. Candidate key again is a closely related concept of your super key. where the super key is reduced to minimum number of columns required to uniquely identify each row. Super key is reduced to minimum number of columns to uniquely identify each row. So here we are taking example, a table customer master contains the following columns. What columns? Customer master, again a new table. Okay, customer master. Alright, so what are the different columns? We have customer name, then we have customer ID. Okay, SSN, your security number. Okay, then address and your date of birth. Many columns it have. Okay, these are the columns, different columns which we are having in the customer master table. Now we are going to identify the super key. Super key means this is combination of columns. Minimum number of columns, that is your candidate key. Now super key is combination of columns to uniquely identify in relational database management system, DBMS. Okay. Now name, security number and date of birth. Okay. Name, customer name, right? SSN, that is your security number, and your date of birth. Okay, so your customer name will be unique, maybe it can be different. Security number, obviously each and every person they have some different security number, and your date of birth. When taken together, these three things, they are a super key. So your date of birth can be same date of birth of any people can be there, obviously. Now name can be same, again security number maybe it can also be same, but when we are taking these all together, a particular name with a particular date of birth cannot have a same security number. So these three taken together can be a unique thing, unique combination which will identify your table data uniquely. So here, since it's a super key, so it needs primary key. We were having either mainly we have a column to identify or maybe combination. Candidate key also there we have some maybe one or maybe more than, but super key will be more than one columns. It is number of columns, minimum number of columns, that is candidate key, and here it is number of columns which is identified in RDBMS. We are talking about this super key. So here these three taken together will identify your table, will identify your, that is each row, each particular row it will identify, that is combination of column uniquely identifies a particular row. So these three taken together, name, security number and date of birth. Again another possibility, ID, your customer ID, right, plus your name and your security number. Again this combination can also be, these two are our super key, right? So here customer ID, name and security number. Since customer ID, I have already told you, in case of candidate key we are not combining. Since customer ID is sufficient to identify a particular person, we are not combining it. In super key we can do that combination. We are combining the customer ID with its name and security number. So these three when taken together can identify a person uniquely, can identify a particular row uniquely in your relational database management system. So here what is happening, these three taken in combination, maybe this combination or maybe this combination, when these are taken together they can uniquely identify a person in a particular whatever table we are talking about. Okay, so this is the thing what is happening here. These are our super keys, they are more in number. So this is the what is happening in your super key. Again another thing is our foreign key. So super key is also clear what is happening here. we are taking many columns together to identify a particular row of your table, that is uniquely, right? Now we are talking about foreign key. Foreign key is what? Which is, there is some referencing is there, right? It is a key used to link two tables together. Now we are linking here. What type of linking? I am talking about some department. This is a table, particular table, and employee is a particular table. So these are the two tables, department and employee. Here I have department ID and department name. Okay. Here I have employee ID, employee name, and department ID, right? And address. So these are the tables. So here what you are seeing, this is sometimes called as a referencing key. From the name itself, we are getting it's a referencing key. Up to super key, we didn't have the concept of referencing. It was in the table. Whatever you are going to do, you are going to identify your database, identify your table, identify each row within this particular table. No referencing concept was there. Nothing, you cannot reference with any other data. But here it is called itself as referencing key. So here is the concept of referencing which is coming here, right? Now it is a column or a combination of columns whose values match a primary key in a different table. So when I am talking about two tables, two different tables, now the primary key of a particular table, it is referenced by another table to uniquely identify. Here what is happening, it is just referencing used to link two tables. Here uniquely identifying, that is your primary key of one table, but it is linking the whole table with another table. That primary key, it is used to link with another table, right? How it is happening, let's see. So here, okay, employee ID, employee name, department ID, and address, etc can be there. So this is what is this table and this is what is this table. So here you can see for my department ID, particular department table, what is that? Here my department ID is my primary key. It is the primary key in this case, okay, and department name is something there. Now when I am referencing my this table with employee table, right? So here employee ID is the primary key. In this case, employee ID is the primary key. But when I am talking about a particular employee, right? His name is there, but I want to know this department ID is also present here. But when I am going to search about that particular department, suppose I am working in the HR department. So when I am going to see that what are the criteria of different, what is the thing which is related to this department ID. So here some department ID D001 is given, and here also D001, D00. So these are different departments in a particular place. Hey, it can be HR, it can be whatsoever. So this particular thing is referencing to this table. When you will see this department ID, then this person is working in this department ID. ID is given. What department he is working? I want to know this person is working in which department. What I will do, from this department ID, I will just put this department ID and this will reference me to this table. It will take me to this department table. From there I can know, yes, so this so and so department is the department where the person is working. So there I will come to know about the department details. But in this employee table, I am going to get the details about a particular employee. But here I am not going to get the details of the department where he is working. he is working in a department D001. But what is that department? So that is the, it is the finance, or it is the HR. So this D001 will reference me to the department table, where I will come to know about the particular person's department name and the details about that department. This is what is the working of our particular referencing key, that is your foreign key. So here what is happening? So foreign key department ID, which is the primary key of the table department, will be the foreign key of your employee table. So here it is working as the foreign key, right? Here it is working as the foreign key. It is the primary key of department table, but it is the foreign key of your employee table, since it is referencing, or it is just making a relationship between these two particular table. It is linking a particular table. So the department ID is the primary key of department table, but it is the foreign key of our employee table. So this is what is known as, in it is going to be told, tell about the your foreign key, or about your referencing key. We can call it as foreign key or referencing key. It is very important, right? In the student table also you can do that one, that here the department ID, CS, whatever department is given here, and here the student name, student ID. So here the student name is there, or student ID is there, again department ID, and maybe the marks. So here you can see the name of the student, the ID of the student, and the department and his marks. So if you are seeing this, yes, this student have scored this and this marks. So from which department he is from? So that time this department ID will show you, yes, he is from ID department, or he is from CS department. So also there is also the referencing. It is working as the referencing key. So referencing key means it is linking, it is a link between two tables, right? Now the last one is our composite key. What is composite key? A composite key is a key which have two or more columns which uniquely identifies each row of a table. Again the same thing. It's a composite key is also a key which have two or more columns, maybe two or more, not one, two or more columns. Okay, one column not applicable, only two or more columns which can identify each row of a table. So again here ID and your name and your address and maybe security number. So again ID, name and your security number can be taken together to write a composite key. Basically what is important in this DBMS is your primary key and your foreign key, and candidate key when combination, and super key. More than candidate key can also be, here you can see a column or set of columns, but super key is a combination of column. The best among the candidate key is your primary key, which is also the special candidate key which can uniquely identify, and super key more than one columns. It is used in RDBMS, relational database management system. So these are the particular thing which is there in your keys. So keys are basically, it is going to tell you about your relationship, entities, attributes, uniquely identifying them. So this is very important, this chapter about the keys and what we have studied in your mapping cardinalities. If you have any kind of confusion, any kind of queries related to these two topics which we have studied today, or any previous topic, you can ask me in the comment section. If you have any suggestion, you can give me that also. I am welcoming all your suggestions, and if you like my channel, then please share it and like it, subscribe my channel. Till then, take care.